Assalamu alaikum. In this lecture, we will study how to apply material balance on chemical process plant. The process plant here is ethanol plant. First of all, we will start from the given information and we will see that how to apply the degree of freedom analysis, and we will check it how this system has 0 degree of freedom. Ethylene is actually reacting with water. Now that reaction is called hydration reaction, because when water is involved in as a reactant, then that is called hydration reaction. And here the hydration of ethylene reaction is taking place and ethanol is actually producing. So commercially it is producing commercially. Ethanol is producing at a larger scale in a continuous process plant, but due to some reaction conditions, the side reactions are also happening, which is the production of diethyl ether, that is undesired products, and we have to suppress this reaction, which is happening in this way, but we cannot make this reaction as to not occur at any cost, but we have to decrease this reaction, this products. So the feed to the reactor contains ethylene, steam and inert gas. I'm just drawing this on the flow chart. First of all, you have to draw the reactor. Here 3 reactants are coming. First one is steam, second one is ethylene, and the third one is inert gas. Inert gas is actually a material which is not reacting in the process, which is not taking place in any kind of reaction, which is just coming in the feed and going in the products as it inform, as in amount in which it is coming and in which it is appearing. So the products from this reaction are ethanol. As you can see it, ethanol is producing in the first reaction, and the second product is diethyl ether. We are labeling it as diethyl ether. And this third product which is producing is water. So this is your product gas, and we can say that any discharge from the reactor is called the reactor effluent. It's called the reactor discharge. And the composition of this reactor effluent is given as 243.3 mole percent ethylene. The composition of ethylene is given, and the composition of ethanol is given, and the composition of ether is given. Ethylene is 43.3. Diethyl ether composition is 0.14. And inert composition is 9.3, and the remaining is water. You can subtract all the composition from the 100, because all composition makes the percentage composition make 100 total, and you can easily subtract from this 43.3, 0.14 and 9.3. that gives you 47.26% water, which is producing in this process plant. So in this question, we are just taking the basis of 100 moles of effluent gas. This information is given in the question statement that you have to take the basis of 100 moles of effluent gas. What is the basis of calculation? Basis of calculation is the amount which from which we select them and we start our material balance. So in this case, when the basis of calculations are given, we can easily calculate all the molar composition of the product gases. So the N1 is the mole composition of water, N2 is the mole composition of ethylene, and N3 is the mole composition of inert. So these three are unknowns, and we have all the other compositions known. So the next task is to perform the degree of freedom analysis based on the atomic balance. When there is chemical reaction, it is preferable to perform the degree of freedom by using atoms, by using elements, because it is common that atoms or elements never destroy their identity. The atoms, like in this reaction, carbon is atom, hydrogen is atom, and oxygen is atom. All carbon, hydrogen, and oxygen are appearing in the products. Carbon is appearing, hydrogen is appearing, and oxygen is appearing. So all the elements, all the atoms which are coming in the reactants, which are coming in the feed, they are appearing, they are existing in the product as their elemental state or atomic states. So what is degree of freedom? Degree of freedom is actually telling you the solubility of any system. It tells us that how we can solve the question, how we can perform the material balance. It is solubility. It tells about the solubility of any chemical process plant. So here there are three unknowns, and all these unknowns are N1, N2, and N3. And there are four, there are three atomic balance. First one is carbon, second one is hydrogen, and third one is oxygen. So number of unknowns and number of material balance equation are equal. So this system has 0 degree of freedom. It means that all unknown variables and all number of material balance equations are equal. So you can easily apply the material balance by using this approach, and you can start very basic laws that when some inert is coming in the feed, the benefits of inert in the question statement, in the problem statement, is that we can directly apply first material balance on this inert, because moles of inert which are coming in the reactor, they will go out from the reactor as they are coming in the feed, because an inert does not take part in any chemical reaction, it does not involve any chemical reaction. So this was the task of this question, how to apply, how to perform degree of freedom analysis, and what does it mean that when your system approaches, when your system gains 0 degree of freedom, what does it mean? So I hope everything is clear to everyone. Thank you.